Hello students, welcome back to YouTube channel of Vidya Kshetra, which is a digital platform for KG to PG students. On this platform, we will provide academic content related to all sectors of students from KG to PG. And myself, Sreenivasulu, your maths teacher on this platform. So this is my voluntary contribution to the channel. So please subscribe the channel and please put your valuable comments so that we can improve. And also please visit our website which is provided in the description. So let us continue our discussion on quadratic equations that we did in the last video. So let us continue with that. So let me start by discussing about the relation between the roots and coefficients. So we know that the general form of quadratic equation is ax square plus bx plus c is equal to 0, where a, b, c, these are called coefficients. These are called coefficients. A is coefficient of x square, b is coefficient of x, and c is coefficient of c. C is just a constant, I'm sorry, c is just a constant. And we are going to derive the relation between these coefficients and the roots of the equation alpha, beta. So let us assume that alpha and beta are the roots of this quadratic equation. As you know very well, any quadratic expression which is in this form, which can be written in terms of its roots this way: if alpha, beta are the roots of the equation, then that equation can be written in this form. Right? So I can understand why you are wondering. Many people, many students do mistake here. So they just avoid A here. So which is a wrong representation. Whenever you are representing quadratic expression, simply f of x. I'm not talking about quadratic equation, my dears. So whenever you are representing f of x itself, quadratic expression itself, then you should not miss A. If you are representing equation itself, here I'm writing, if you are representing equation itself, then you can skip. Why? Because even if you put A here, since A is constant, if you send A the side, that will be 0. So here there is no issue. But here, when you are representing the quadratic expression itself, you should not miss A. Right? So now let us see the relation. So I am expanding this. This is equal to A into x, x square minus beta x minus alpha x plus alpha beta. This is equal to A into x square minus alpha plus beta of x plus alpha beta. I have taken x common here. I hope you understood. So this is equal to ax square plus bx plus c. Ax square plus bx plus c. Now let me take a common on left hand side. So I'm taking a as common. So here I will get x square plus b by ax plus c by a is equal to a into x square minus alpha plus beta of x into alpha beta. I hope you got it. Now a and a get cancelled. So here I get x square plus b by ax plus c by a is equal to x square minus alpha plus beta of x plus alpha beta. Now compare the equivalent terms. So that means you need to compare x square term with x square term here, x term and x term here, and constant term here with a constant term here. So x square term, they are equal, right? No need to compare. So here the x coefficient is b by a, whereas here the x coefficient is minus alpha plus beta, which implies that alpha plus beta is equal to minus b by a. Similarly, here if you compare the constant terms, this is c by a here it is alpha beta. So if you compare constant term, c by a is equal to alpha beta. So I can rewrite this, alpha beta is equal to c by a. So this is very important result. This is the relation between the coefficients and roots of the quadratic equation. You can also say sum of the roots is given by minus b by a, where b is coefficient of x and a is coefficient of x square. And product of roots is equal to c by a, where c is constant term, a is coefficient of x square. This is very important result. Yeah. So let me continue. So wherever you stuck, wherever you got any doubt, please comment in the comments. So we will try to address whatever the doubt you have. Please don't hesitate. Now let me continue. The quadratic equation in terms of the roots. Quadratic equation in terms of its roots. So if alpha and beta are roots of the quadratic equation, then this is not very new. Few minutes ago you have seen. So once again, for your understanding, I am writing the result. So then the equation, it can be written as x square minus alpha plus beta x plus alpha beta is equal to 0. So any equation, if you know the roots of the equation, then you can write the equation in terms of the roots like this. Okay. Also, if the equation is given, or let us replace a with 2, b with 8, and c with 24, for example. Now from the given equation you can identify what is alpha plus beta, what is alpha beta by comparing this standard form with this, right? So what is alpha beta here? So before going for that, you need to see whether it is in the standard form or not. Is this in the standard form? No. In the standard form, the coefficient of x square must be 1. So you need to divide the given quadratic equation with 2 first to eliminate the coefficient of x square. So if I do that, I get 2x square by 2 plus 8x by 2 plus 24 by 2 is equal to 0, which gives me x square plus 4x plus 12 is equal to 0. So now I can write that alpha plus beta is equal to, alpha plus beta should have a negative sign, but to have a positive sign here. Okay, so alpha plus beta should be minus 4 when you compare, and alpha beta, you have 12 here, you have alpha beta plus alpha beta here, so this should be 12. So you can extract alpha plus beta and alpha beta like this from the given equation, right? For example, let us solve a problem here. Let us suppose that this is your given equation, x square plus x minus 12 is equal to 0. This is your given quadratic equation. So now if you are asked to find if alpha and beta are roots of the QE quadratic equation, x square plus x minus 12 is equal to 0. If you are asked to find, for example, alpha minus beta, okay? So how to proceed? So you know that to solve this equation, you need to use some basic result that you learned in your high school in the topics of maybe algebra and the concept of exponents. So now I'm going to give that. So you might have seen this equation, a plus b whole square minus a minus b whole square is equal to 4ab. So here if you want a minus b whole square, what you need to do? So a minus b whole square is equal to a plus b whole square minus 4ab. Now if you want a minus b instead of a minus b whole square, that is equal to plus or minus a plus b whole square minus 4ab. And this we are going to use here to find alpha minus beta. So let us find alpha minus beta is equal to plus or minus, what is alpha plus beta? When you compare here, alpha plus beta is minus 1 whole square minus, you should compare this equation with the standard equation. So in place of alpha plus beta, you have minus 1, right? So alpha plus beta 1 is equal to minus 1 here. So minus 1 whole square, or I can write separately. So from our discussion, alpha minus beta is equal to plus or minus alpha plus beta whole square is equal to plus or minus square root of alpha plus beta whole square into alpha plus beta whole square minus 4 alpha beta. So here if you compare x square plus x minus 12 is equal to 0, here the coefficient of x is 1, so which means that alpha plus beta is minus 1. Alpha beta, here the constant term is minus 12, so alpha beta is equal to minus 12. So now alpha minus beta is given by plus or minus, simply substitution will lead you to the solution. So alpha plus beta is minus 1 whole square minus 4 into alpha beta is minus 12. So this is equal to plus or minus 1 plus 48 is equal to plus or minus 49 is equal to plus or minus 7. So this is how you can use this fundamental relation between the coefficients and roots of the equation. I hope you got it. So there are many problems given based on this concept, which is very simple concept, but will help you to score well in your entrance examination, in particular JEE Mains. So let us consider various terms here. Let us take the same equation. Okay, so for which alpha beta are the roots. Then let us find alpha square plus beta square. Once again, we will be using the one of the basic concepts that you have learned in your high school. So a square plus b square solution. So alpha square plus beta square is nothing but alpha plus beta whole square minus 2 alpha beta. Alpha plus beta whole square is equal to alpha square plus beta square plus 2 alpha beta. So we want alpha square plus beta square itself. So we need to subtract 2 alpha beta from this. So now you know what is alpha plus beta. Alpha plus beta is 1 minus 1 whole square minus alpha beta is minus 12. This is equal to 1 plus 24, 25. I hope you got it. Similarly, you can say, let us consider various quantities here. Alpha cube plus beta cube. Once again, we can use the basic results that you have learned in your algebra and exponents concepts. So a cube plus b cube is given by a plus b whole cube minus 3ab into a plus b. Right. So now you can apply here a minus b. I'm sorry. Yeah. So you can apply here. So alpha plus beta is given minus 1 whole cube minus 3 into alpha beta you can get from here minus 12, and alpha minus beta we have calculated previously just few minutes ago, which is plus or minus 7 we got. Let us take the positive quantity a 7. So now we got minus 1 plus so you will get yeah, so 736 into 7 42 252, which is 251. So this is how you can calculate. You can calculate this by some other formula also. A cube plus b cube is given by a plus b into alpha square a square minus ab plus b square. So here alpha plus beta is known, which is a minus 1. Alpha square plus beta square we have just now calculated 25, and alpha beta is minus 12, so minus of minus 12, which is equal to minus 1 into 25 plus 12. We are getting some random result. Let me check. So minus 1 into 7, 37, which is equal to minus 37. So let me check where it went wrong. So here a cube plus b cube is equal to a plus b whole cube minus 3 alpha beta plus alpha plus beta, right? So I think here I did mistake. So you can check, you are supposed to get the same quantity whatever you got here. So alpha plus beta is minus 1. So now this it becomes minus 36, which is minus 37. I'm sorry, please find the correction here. It is a plus b, it's not a minus b. I'm sorry. Yeah. Now just like this you may consider many terms. Let us take 1 by alpha plus 1 by beta. If you are asked to find, these kind of questions were asked in JEE Mains. So if you are asked to find this, then it can be determined by simple approach. So let us say the LCM is alpha beta. Now it is beta plus alpha. So alpha plus beta is minus 1 and alpha beta is minus 12, which is 1 by 12. Yeah. So this way you can find many combinations. So whenever you get such questions, you can apply just the relation between coefficients and the roots and identify alpha plus beta and alpha beta, then it is a very simple. I hope you got it. So this representation, whatever you have discussed, we have discussed here, x square plus alpha plus beta x plus alpha beta is equal to 0. This please remember. Why? Because this is going to help you when you deal with cubic equations, when you deal with polynomials with exponents degree greater than 3, greater than 3, greater than 4. Okay, whenever you deal with such polynomials, this representation is going to help you. Once again, I will recap when I do that in the video. Yeah, so let us continue. I hope you can follow. So wherever you have any doubt, please comment in the comment section. So now let us continue the nature of the roots that we discussed the other day. Nature of the roots. Nature of the roots. So there we have noticed that if the quadratic equation is ax square plus bx plus c is equal to 0, if the quadratic equation is ax square plus bx plus c is equal to 0, the coefficient of x square will affect the function, will affect the quadratic expression. Will tell you how the quadratic expression is it concave up, is it concave down, does it have maximum value, does it have minimum value, what are the maximum value, what are the minimum values. All these details will be given by quadratic expression. Whereas when you consider quadratic equation, that will give you the roots of the equation or the solutions of the equation. Right, this is the difference we have discussed already. Now let us recap what we discussed the other day. A should be non-zero. A should not be equal to 0. If A is not equal to 0, then it can be either positive or it can be negative. Let us consider various cases here. And when I say when I talk about nature of the roots, if you recall, there is an important parameter called discriminant. There is an important parameter called discriminant, which is represented by d, which is defined as b square minus 4ac. This is going to affect the nature of the roots. So if you want me to recall, if d is greater than 0, we can say that the roots are real and distinct. If d is equal to 0, you can say that the roots are real and equal. If d is less than 0, there are no real roots exist and roots are imaginary. Right? So let us see how they can be represented graphically here. So if this is greater than 0, let me draw. This is x-axis, this is f of x, or y-axis you can say. Now if I plot f of x for this case, it may look like this. If d discriminant is greater than 0, f of x looks like this, where the points of intersection between f of x, this is f of x, the points of intersection between f of x and x-axis, they are nothing but roots of the equation, alpha and beta, So clearly, whatever we discussed, roots are real, alpha beta are real numbers, and distinct. You can see two different roots are there, both are real numbers. When I say real numbers, I mean that they exist in reality. Okay, we have actual roots. Let us see the other part. D is equal to 0. If D is equal to 0, once again if we plot f of x, this is f of x. So if I plot, the function looks like this. Let me change the color. The function looks like this. It intersects, the function intersects the x-axis only at one particular point. Okay, so that means the function has two roots even now, but they are repeated roots, alpha and alpha, equal. So I can write here that roots are real and equal. Roots are real and equal. I hope you got it. Third case, D less than 0. Discriminant is negative. So in this case, let us see, if I plot the function f of x with respect to x, it looks like this. So you can see there is no point of intersection between f of x and x-axis, which means that here I can write this conclusion that no real roots exist and the roots are imaginary. The roots of imaginary. The roots are imaginary somewhere here. There are no real roots exist. There is no point of intersection between f of x and x-axis. Yeah. So this is for the case where you are considering positive a. So let us consider the negative a. A is less than 0. Let us consider all the cases. If d is greater than or equal to greater than 0. If d is equal to 0. And what happens if d is less than 0? Let us see all those cases. So once again I am going to do the same exercise. So if a is less than 0, which means that the function is still concave in shape, but concave down. Parabolic, concave down. Okay, these are concave up. Why? Because a is greater than 0. If a is less than 0, the function is concave down. So it can be drawn like this. So it faces down. That's why it is concave down. So now you have two intersections here, alpha and beta. So we can write roots are real and distinct. Two different roots and distinct. Now, similarly, for d is equal to 0, so still we have intersection between f of x and x-axis, but only at one particular point. So we can say there are real roots, alpha and alpha repeated. Okay, so I can write that roots are real and equal. Next case, d is less than 0. So once again I can repeat the same approach. This is f of x. So when d is less than 0, when discriminant is negative, you may have something like this. So still it is concave down, but there is no intersection between f of x and x-axis. Hence we can say that roots are imaginary. No real roots exist. Okay, so cases will match, both the cases, different cases of I'm sorry, discriminant matches in both the cases of a greater than 0 and a less than 0. I hope you got it. Yeah. So here one more insight you can see when you see these two cases, this case and this case. Okay, so you can say that you can write conclusion here like when a is greater than 0, when d is less than 0, your f of x is strictly greater than 0. This is very, very important conclusion. When a is greater than 0, when d less than 0, your f of x will be greater than 0 always. Okay, absolutely. Well above the x-axis. It is above the x-axis, means f of x is greater than 0. Similarly, when a less than 0, when d less than 0, your f of x will be well below the x-axis, which we can say f of x is less than 0 for all x. This is also very, very important. See, once again, when a is greater than 0, when d is less than 0, f of x is always greater than 0. When a is less than 0, when d is less than 0, f of x will always be less than 0. Always f of x will be negative here, always f of x will be positive here. Whereas if you see the other cases, when d is equal to 0 and a is greater than 0, f of x is greater than or equal to 0, and in this case f of x is less than or equal to 0 here for a zero discriminant case. For zero discriminant case with positive a, f of x will be greater than or equal to 0. For zero discriminant with the negative a, f of x will be less than or equal to 0. These results are very, very important. Now for the first case, partially it is positive here in this region, and similarly it is negative here in this region. First case, here also partially it is positive here and partially it is negative here. So these are the three cases you need to consider. These are the important points you need to take. So once again I repeat, in the first case, partially f of x may be positive and negative. Here also positive and negative. In the second case, if a is greater than 0, f of x may be greater than or equal to 0. In a is less than 0 case, f of x is less than or equal to 0. If a is greater than 0, f of x is always positive if a is greater than 0 and d is negative. F of x will be always negative for all values of x if a is less than 0 and d is less than 0. Okay, these things are very, very important. You need to remember. I hope you got it. So once again, if you can't understand anything, please give your valuable comments. So these results will be using when you are trying to find the location of the roots. There it is very, very important the maxima and minima values of quadratic expression. quadratic expression will have maximum value or minimum value. I'm sorry. Quadratic expression will have maximum value and minimum value. Quadratic equation will not have maximum value and minimum value. So when question is asked, when they give the equation, if the question is asked what is the maximum value or minimum value of, you need to consider quadratic expression, not quadratic equation. That we will see later. I hope you got it. Now let us see another important concept. Common roots. Common roots. Okay. So like you may be given two equations, two quadratic equations. a1x square plus b1x plus c is equal to 0, c1. a2x square plus b2x plus c2 is equal to 0. Okay. So there are some conditions if you have common roots between these two quadratic equations, right? If you don't have common roots, there are no conditions, obviously. And if you have common roots, how many roots a quadratic equation can have? 2. So there may be one common root between these two, alpha, or there may be a case where both the roots are common. So for both these equations, the roots may be alpha, beta. Right. So if that is the case, what are the conditions we need to apply? This is very important concept. You have questions given in previous JEE Mains examinations. You may refer. We are going to solve problems also on this. Okay. So let us see what are the conditions first. Yeah. So let us take case 1. Only one root is common. Only one root is common. Okay. Let us say alpha is common between these two. Okay. So let us see what is the condition for that. So if alpha is common, that means I can substitute a1 alpha square plus b1 alpha plus c1 is equal to 0. Similarly, I can substitute in second equation a2 alpha square plus b2 alpha plus c2 is equal to 0. Since alpha is common between the common root for both the equations, I can substitute in place of x, I can substitute alpha in both the equations. Okay, it is very obvious. So now we are going to solve this equation for these two variables. Okay, so for the time being, let us just to make it simple without any confusion, let me substitute alpha square with p and alpha with q. So if I substitute, I get a1p plus b1q plus c1 is equal to minus c1. a2p plus b2q is equal to minus c2. So we are going to solve these two linear equations for p and q, right? So if we solve, I hope you have studied, those who are studying 11th standard and 12th standard in various state boards and or CBSE or ICSE, I hope you are familiar with some matrix based method, or sometimes it is also called cross coupling method, right? So Cramer's method, matrix method, if you apply, first of all we'll be finding determinant det value, so which is equal to a1 b1 a2 b2. So this is given by a1 b2 minus a2 b1. So if you want this variable, if you want this variable, then that is given by 1 by det value into determinant of, so you will be replacing this with the constants whatever you got, minus c1 minus c2 b1 b2. This is equal to, if you cross multiply, b1c2 minus b2c1 by determinant value we have calculated here, a1 b2 minus a2 b1. I hope you got it. So P is equal to, so P means alpha square. Alpha square is equal to, so this is alpha square. Similarly, let us find what is Q. So Q is equal to 1 by determinant. A1, A2 will be taking. So please see here, please see the method. Determinant can be obtained by taking the determinant of, taking the matrix of the coefficient matrix A1, A2, B1, B2. So determinant means cross multiplication. This is the value. Cross multiplication and subtraction, right? Similarly, when you are calculating the variable, solving the equation, you should take the 1 by determinant multiplication factor and replace the matrix with, you should whatever the variable you are trying to find, and that place should be substituted with minus C1 minus C2, and remaining variable coefficients you should take as it is. Okay, so I will do this when I do matrix theory, linear algebra. Okay, for the time being you can learn this way, or you can use your any conventional method, cross multiplication method. Oh, this is very simple, right? Now here, since we are solving for Q, I am replacing B1 B2 with minus C1 C2. So now this is equal to minus A1 B2 minus A2 B1, 1 by A1 B2 minus A2 B1 into cross multiplication. If I do C1 A2 minus C2 A1, I will get. It is like A1 minus C1 minus A1 C2 minus of minus A2 C1 you will get. So that I have rearranged. So now this is equal to C1 A2 minus C2 A1 by A1 B2 minus A2 B1. This is Q, which is equal to alpha. So you have determined alpha square is equal to some expression here, and here you have determined alpha is equal to some expression. So what is the condition here? Alpha square, whatever you write here, okay, this should be equal to square of this alpha, right? So alpha square value you got here. So B1 C2 minus B2 C1 divided by A1 B2 minus A2 B1 is equal to, I am going to square this. So C1 A2 minus C2 A1 divided by A1 B2 minus A2 B1. Alpha square is equal to square of alpha. Now, if I apply square here, C1 A2 minus C2 A1 whole square divided by A1 B2 minus A2 B1 whole square. Now this term and this square get cancelled, and if I cross multiply, I will get B1 C2 minus B2 C1 into A1 B2 minus A2 B1, or let me rewrite so that you can remember easily. A1 B2 minus A2 B1, B1 C2 minus B2 C1 is equal to C1 A2 minus C2 A1 whole square. This is the condition if you have only one root is common. If you have only one root common. If you have only one root common, right? So please see, this is the derivation. Derivation is not expected in the JEE main, but if you understand the derivation, you can remember the formula. This is the intention behind explaining the derivation, right? So now you can see here, you can remember the way, you can remember I'm going to explain. If you have only one root common, this is how you can remember. A1 B2 minus A2 B1 into B1 C2 minus B2 C1 is equal to C1 A2 minus C2 A1 whole square. This is how we can remember. Just cross multiply. A1 B2 minus A2 B1 into B1 C2 minus B2 C1 is equal to C1 A2 minus A1 C2 whole square. This is how you can remember. So this is the condition when you have one root as a common root. So let us see the other case. So case 2, which is nothing but two roots are common. This is relatively very easy to derive and also relatively very easy to remember too, right? So now let us see if alpha beta are common, right? So what can I write? So here also the roots are alpha beta and here also the roots are alpha beta. So I can write for the first equation, for the quadratic equation, a1x square plus b1x plus c1 is equal to 0. Alpha plus beta is equal to minus b1 by a1. This I have explained. And alpha beta, the product of roots, is equal to c1 by a1. Similarly, for the second quadratic equation, alpha plus beta is equal to minus b2 by a2 and alpha beta is equal to c2 by a2. C2 by A2. So this we have discussed clearly, right? So now let us say alpha plus beta is minus b1 by a1, alpha plus beta is minus b2 by a2, alpha beta is c1 by a1, alpha beta is c2 by a2. So now I can compare these two sets of equations. Let me say this is set number 1, this is set number 2. So if I compare, what I get, so here also you have alpha beta and here also you have alpha plus beta, here also you have alpha plus beta. So now if these two are equal, these two must be equal. So that means b1 minus b1 by a1 is equal to minus b2 by a2. You can cancel the minus. So now I can rewrite this equation as a1 by a2 is equal to b1 by b2. Now let me compare these two. Here also it is alpha beta, here also it is alpha beta. If these two are equal, these two must be equal. So that means c1 by a1 is equal to c2 by a2. I can shuffle. So a1 by a2 is equal to c1 by c2. So this is one set I got. This is another set I got. Here I have a1 by a2, here also I have a1 by a2, here a1 by a2 is b1 by b2 and here a1 by a2 is c1 by c2. So I can consolidate these two as a1 by a2 is equal to b1 by b2 is equal to c1 by c2. This is the condition if you have two common roots for two given quadratic equations. Based on this, once again, problems are expected. I hope you got it. Yeah. So with this, I'm going to conclude the lecture. So tomorrow, in the next video, we will meet again. So whatever the doubt, it may be silly also. So whatever the doubt you got, please subscribe our channel first, and please mention your doubts and queries in the comments, so that we can improve, and we can give you improved and improvised services, so that each and everyone from KG to PG can use the facilities of our channel. Thank you. Thanks for joining. See you in the next video.